All right, Honor Geo students, this is the last video of Chapter 8. In Section 8.6, we're just going to review all of the different properties that we have been covering throughout this whole chapter. And so we're going to take a look at this chart. This is posted on Moodle, and this is something you're going to want to print off because it kind of is a good way to summarize what we have been doing throughout this chapter and really make you think through what's true about the properties of each of these quads. So what I'm going to help you do, though, is to fill out at the top the diagram. So what we want you to do on the marked diagram is to make it so that the definition for each of these quads is represented by the markings on the diagram. So if we look at each of these quads, the way I have them drawn right now, they all look like they're squares. But we can mark the diagrams so that we would be able to identify each as the specific quad above. So if I'm talking about a parallelogram, the definition of a parallelogram is that opposite sides are parallel. So if all I have marked on my diagram here is opposite sides parallel, then the most specific name that I could give this quad would be a parallelogram. Okay, similarly, if we move to a rhombus, definition of a rhombus is all four sides are congruent. So if those are the only markings on there, even though it looks like a square, the most specific name for that quad would be a rhombus. Okay, definition of a rectangle, all four angles are right angles. So I can draw those in and mark that on my diagram, identifying this quad as a rectangle. And then our square, the only way, even though they all look like a square, to make it a square is if I do all four angles right angles, and all four sides are congruent. That's the definition of a square. And then a kite, remembering that that is when we have consecutive sides congruent, two pairs of them. So there are two pairs of consecutive sides congruent. A trapezoid has exactly one pair of parallel sides. So I'm going to draw in exactly one pair of parallel sides. And then specifically an isosceles trapezoid has one pair of parallel sides and the legs are congruent. So if you look at these, by putting those markings on these diagrams, I've now differentiated all these quadrilaterals, even though they all look like squares. If I go off the markings that are on the diagram, I know what type of quad each represents. Then what you're going to do in this diagram is just fill out yes or no as to whether or not the properties hold true. So if I'm looking at a parallelogram, opposite sides are equal, that's true, so yes. Okay, opposite sides are parallel, that's true. Opposite angles are equal, that's also true. The diagonals bisect each other, that's true. Complementary angles are supplementary, or consecutive angles, sorry, not complementary. Consecutive angles are supplementary, that's true. All sides are equal, that's not necessarily true. And so you want to say yes only if it's always true. Diagonals are perpendicular, that's not always true in a parallelogram, so my answer is no. The diagonals are equal, same thing, not always true. And the angles are right angles, not always true. So the big key as you're filling this out is to realize that the only time I answer yes or true is that if it's always true for that quadrilateral. So you are going to work through filling out the rest of this chart. You can work on that with your group tomorrow in class if you want to make sure you have that printed out. And then you're also going to want to print this off as well because you're going to be going through these and identifying this as true or false. We will see you tomorrow in class.